Here we have f of x equals 1 over x minus 6, and our goal here is to find the domain. Okay. Well, before we do that, let's start with a fact of math. A fact of math is that we cannot divide by 0. Cannot divide by 0. That's just a fact. And we can talk about why that's a fact. I guess one way to think of it is that this would be infinity, but really we can't tell if it's positive infinity or negative infinity, so we say that it's undefined. Right? If you don't believe me, try dividing 1 by 0 in your calculator. Your calculator will protest. Right? You can't do it. And one way to get an idea of why this is the case is try dividing by something very close to 0. So let's divide 1 by 0.000001. Okay, you can do that and you'll get something very big. I don't know what. It's going to be a big number. The smaller this number gets in the denominator, the bigger the whole thing becomes when you divide it out. Right? And you can imagine then going closer and closer to 0 in the denominator would get us off blowing up to infinity. So we say it blows up when you divide by 0. That's an analytical reason of why you can't divide by 0. There are also algebraic reasons that you can't divide by 0. And you know what? I'm going to save those for a future math class because that's getting a little off topic. The point is you cannot divide by 0. Okay, what does that have to do with this exercise? Well, what that tells us here is that this denominator part cannot equal 0. Because if that equals 0, then we're dividing by 0. So I'm going to take this and I'm going to say x minus 6 cannot equal 0. All right, and we're going to solve for x. Essentially, I'm going to add 6 to both sides. So that gives us x cannot equal 6. Right, and that kind of makes sense, right? If we were to plug in 6 here for x, we would get 1 over 6 minus 6, which would give us 1 over 0. No, we can't do that. So we have to take x equals 6 out of the domain of f of x. Every other value of x is fine, it's just 6 is forbidden. So here's the domain. How do we say that mathematically? We can't just leave it like this, x is not equal 6. That's not exactly what we want, although that's really fine, but we want to put this in interval notation. So in interval notation, here's how we do that. We want to say everything except for 6. So we include everything. We're starting all the way down at negative infinity. We're coming all the way up to 6. We're stopping infinitely close to 6. That's why I'm using the soft parentheses there instead of a hard bracket. We union across to the other side of 6. This union symbol joins these two together. And what this means is we're jumping over the mathematical point 6 and starting just on the other side of 6, infinitely close to it, but not actually touching the point 6 off to infinity. So this here is how we say in interval notation every single point except for 6. Graphically, right, this looks like this. Here's our number line, here's 0, here's 6. Okay, so I am going to take every number except for 6. So I'm going to leave out 6. There we go. I go off to the right to infinity, go off to the left, and I leave out one mathematical point. So drawing this circle really doesn't do it justice. I would have to draw an infinitely small circle, because how do you draw a circle around a single mathematical point? What would be the radius of that circle? Right? These are questions that mathematicians ask, and you study. If you become a math major, you would answer questions like that. What does this mean to get infinitely close to 6? For now, we'll just leave it as a circle, infinitely close to 6, hop over it, start again on the other side. This is our domain.